Most YouTube analysis tools show you scores, keywords, and top 10 lists. But these numbers hide a dangerous trap. They tell you what exists but never explain what is missing. For months, I made video decisions using disconnected spreadsheets. I tracked keywords in one tab and competitor uploads in another. The screen filled with data but gave me zero clarity. You can optimize a title to score 90 out of 100 on an online checker. Yet, that video can still fail completely. An isolated score cannot see the wider conversation in your niche. To find real opportunities, you must look at structural relationships. You need to connect videos, tags, topics, and competing channels into a single living graph. Data fragmentation is the root issue. Standard keyword trackers only show search volume. They treat every phrase as an isolated island, completely blind to surrounding concepts. Competitor tracking tools suffer from the same flaw. They record view counts and upload dates, but they cannot tell you why a specific video resonated with the audience. When you rely on disconnected slices of data, you miss content gaps. Even worse, you miss the structural reasons why certain topics remain completely underserved. That is why I built TubeForge. It is a local growth engine written in pure Rust. It ingests public channel data and builds an in-memory knowledge graph directly on your computer. Everything stays on your local machine. There are no cloud servers, no paid third-party scrapers, and no monthly fees. You own your research data completely. TubeForge includes a standard input-output JSON-RPC bridge. This allows AI coding agents like OpenCode or CloudCode to query the graph and run deep analysis autonomously. The workflow starts with keyless metadata ingestion. TubeForge fetches recent public uploads using standard RSS feeds and video embeds without consuming daily API quota limits. Next, the embedded database writes each entry to a write-ahead log. The engine indexes titles and descriptions using a custom BM25 search algorithm. TubeForge then constructs the graph. It runs Louvain community detection to group related videos into topic clusters and uses PageRank to calculate node authority. Now comes the power of OpenCode. I can ask natural, highly specific questions. Where are the coverage gaps? Which clusters have high search interest but weak video depth? The agent queries TubeForge, traverses the graph edges, and returns answers with complete provenance. You do not just get a recommendation, you get the exact data that proves it. Let us look at a real example from my own channel research. I analyzed 5 major channels covering systems programming and backend architecture. The knowledge graph surfaced a high relevance topic cluster connecting memory allocators, cache lines, and log-free data structures. When OpenCode examined the transcripts, it isolated the core issue. None of the 5 channels had a dedicated video on cache-friendly data layouts. Every creator treated cache coherence as an offhand remark inside larger tutorials. The audience was searching for a first principles explanation, but nobody had built it. That single graph insight shaped my entire next video. Instead of guessing what might work, I built the exact deep dive the ecosystem was missing. This shift replaces creative anxiety with engineering conviction. You no longer chase arbitrary keyword trends. You build solutions for proven, visible structural gaps. When you combine local-first storage with autonomous AI agents, research becomes fast, private, and deterministic. You spend less time searching and more time building. TubeForge is completely open source under the MIT and Apache licenses. You can inspect the code, build the binary, and run the same workflow on your own machine. Now, the one critical piece we did not cover in this video is how to build a local-first search engine from scratch using an embedded database and custom indexing. To fulfill that missing piece, click right here on this full video where we break down the complete architecture step by step.